wonder what a flying car looks like and how it works? Or are you interested in pursuing a career in STEM but just don't know where to start? Or are you just looking for a meaningful way to spend your holiday? Learn from some of the best in the aviation industry as they share their amazing career and the exciting experiences that they have. Explore with innovators and entrepreneurs as they come up with exciting technologies to revolutionize the field. And hear from educators who bring science to life through experiential learning. Aspire Week is here to inspire you. Join us online from 14th to 20th June. See you soon.
Good morning and welcome to Aspire Week, where we explore flying cars, innovation and technology and careers within the aerospace industry. In this session, we have Mr. Ian Lam, General Manager at Schaeffler, Aerospace, Singapore. Ian, welcome to the show.
Hi, thank you for inviting.
Ian, you're a General Manager at Schaeffler Aerospace. Can you tell us a little bit about your role there?
Well, we have what we call a repair station in Singapore. So we service bearings. We are a manufacturer of bearings that goes onto engines like Premier 4000 here in Singapore. And globally, we actually supply bearings to all the major commercial engines today, those that you used to fly. Now we have to say, used to fly when you travel overseas. Those aircraft that you fly. A320, 737, etc. So yeah, that's what we do here on a day-to-day basis. Yeah.
Okay, I mean, I'm sure our audience is looking forward to know more about your operations and the technologies that you're working on. So I shall now leave you to share more, and I'll be back with you at the end to wrap up the Q&A.
Sure. Okay, firstly, hi. Good morning to everyone. Okay, hope you all had a good morning so far. I know there are more sessions after this. I'm sure you all will enjoy yourself and gain lots of insights. Okay, so what I'm sharing today will be about the core technologies that we see that will be required to enable flying cars, right? So I will start with a bit of introduction about what Schaeffler is about first, right? Just to confirm, can I just confirm that you can see my screen, right? Okay, maybe somebody give me a thumbs up or write in the. Is it okay, right? I can go on.
Yes.
Okay, great. I'll just go on because all right. Okay, so this is the agenda. This is the agenda. So we will talk about first. I'll give you an introduction about Schaeffler as an overview, and then we'll talk about cars. The people dream about it for many years, right? And then it will be important in enabling cars to take it, or you want to find out more about what we're doing. That will be the last part of today's session. Okay, first let's talk about what Schaeffler is about first. Firstly, we are a company that pioneers motion. Okay, we are in every area of mobility that we believe is important, and we want to do this in many shapes and forms. So this is some background to the company. We are a German company listed in the German stock exchange. We did about 12 billion euros of revenue last year, even amidst COVID-19. I think then we have a global footprint across many countries, 200 plus locations, over 50 countries. But what I really want to highlight here is that we are a technology company. See on the top right corner, I would say that this is what I'm most proud of as a part of Schaeffler. is that we are not just a manufacturer, we are not just a sales company, but we are a technology company. We filed, I think before this year, we used to file more than 2,000, but I think last year is a bit of a slight slowdown, but we still filed more than about 1,900 patents in last year alone. This usually is in Germany, we are usually the company that files the second most number of patents, right? And I think as you can understand, patents is really the bedrock of all technology development. So we are very proud of that, and we continue to work on that to make sure that we do not rest on our laurels and just be a manufacturer or just a sales company, but truly we want to be at the technological frontier and continue to drive technologies in every area of our domain. So yeah, I think that's the main thing I want to highlight about what Schaeffler is. How we organize our business is on this slide. We are also a player in the automotive industry. You can see that in our 3 divisions in how we organize the company, 2 of it is in the automotive. On the left-hand side, you see automotive OEM. So here we supply entire engine systems, transmission systems, chassis, and hybrid and electric drive even, which we will talk about quite extensively here today, to major car manufacturers like Volkswagen and the likes, right? So that is on the automotive OEM side. And then on the automotive aftermarket, cars will also be on the roads for a while. So we also sell spare parts to ensure the longevity of cars on the road. And then where I'm from, the aerospace part is one of the 8 sectors under the industrial division, right? We do work in areas like wind, raw materials, and of course aerospace, railway, etc. Okay, so this is how we are organized as a company. And then I mean, what I want to show up, maybe coming back here, what I want to highlight here is really that we have a lot of experience that I'm very proud to say that is a cross-pollination, right? Where something that has developed many years in, say, automotive can then be moved into wind or off-roads or raw materials and aerospace and vice versa, right? What we do in aerospace can then be engineered and become a cutting-edge technology in railway or automotive, etc. So this is the strength of what we have as a conglomerate of industrial and automotive company here at Schaeffler. Okay, a bit more then, because today we're talking about aerospace and I'm from aerospace, right? I'll talk a bit more about our footprint in aerospace. Firstly, we are a manufacturer of bearings, right? Like, I mean, the most common bearings that we talk about would be like ball bearings, but there are a lot more bearings than ball bearings, okay? But I'll not go into the detail here, but I just want to say that on all these bearings, as you can imagine, anything that needs to turn, needs to rotate, will actually require some form of bearing to reduce friction, to ensure the turning is smooth, etc. So actually, in all the planes that you take, and then the engines that power them in commercial aviation, the technical term is turbofans. And actually, across all, I think, major commercial aviation turbofans, we have some bearings on it that is made by Schaeffler. Okay. So some of it are like all this here they see on the screen here are what I'll call the growth sectors. We are very successful on all the legacy programs, the mature programs like CFM56, Pratt & 4000, the trend programs that if you're familiar with, you know. But these are really what I would say are the planes that have been manufactured in the last, say, 5 years to 10 years, and they have another 40 years to go, and we have bearings on them as well. Okay, so this is something that we are very proud of, and we look forward to continue to really be on these new generations engines because they are clearly more efficient. They do a lot more in terms of greening the environment, and we are very proud to be a part of them. Okay, so how we are organized within the aerospace business is that we have 5 plants globally. We have one on the top left in Canada, and then the bottom, America, and then Germany. And in Germany, just want to highlight in yellow, you see that it's a IATA Part 21 holder. That really means that we can do design work, design modification in terms of how on approved engine types. Okay, this is a bit complicated, but we can talk about that later on. You can ask me questions later on about that. Then in the two pictures that you see more on the left, on the right hand side rather, Taitang in China. We also have a MRO facility in China that is doing bearing refurbishment for the aerospace sector. And of course, in Singapore, that's what we do as well. We have a facility that does bearing refurbishment for the aerospace business. And of course, I cover the Asia Pacific region. We also look out for opportunities like OEM opportunities where people want to build new things and require bearings, be it in the UAM space or in the traditional commercial aviation space. Okay. On the right hand side, just the picture here is really just some of the major customers that we have in Asia Pacific, right? That we cover as a region. Okay. And then now I think it's really the gist of what I hope to share with you after the introduction. Firstly, this is what I call the inevitability of cars growing wings. Firstly, I mean, cars have been on the road for a long time. So has planes been flying in the sky. But flying cars has always been a dream, but I think we this generation, yourself, myself, are really at the cusp of seeing it happen. And I hope to provide you some evidence and some food for thought to see why this convergence is so real today. Firstly, you see there's an industrial player overlap. On the pictures that you see on the left, on the you see Toyota and then Mercedes and Fiat, right? These are all traditional, even branded, highly efficient in production, very successful automotive companies. And just beside their logo, you also see some names like Joby, Volocopter, Archer. And in those boxes that I put together, actually it means that Toyota has invested in some shape and form with Joby. And then so has Daimler, the owner of Mercedes, in Volocopter. And Fiat has talked about partnership with Archer, which is also, Archer is being another UAM manufacturer. So you can see that there's a clear industrial player overlap where the automotive industries have clearly found it important to be invested, and they have done so in these new UAM companies. And of course, you also would be familiar with, say, Hyundai, who has decided to, in some sense, go it alone, where they are building their own Hyundai branded UAM. So this is really, and of course, you see more recently, more and more companies in the traditional automotive space are talking about how they need to be involved. This picture at the bottom from General Motors, GM, they have, this picture here is a flying car, okay? It is written in the recent CES, where it talks about the latest technology exhibition. So this is a computer rendered graphics. It's a computer rendered graphics, but this nevertheless shows their ambition to have some form of flying cars that in their portfolio. And this picture from Reuters, a snapshot from their website news, is really that Volkswagen, I think as recent as 1 month ago, talked about wanting to explore flying cars in China. So clearly there's an industrial player overlap where the traditional automotive players are moving into this exciting new space. They want their cars to fly, if you put it colloquially. Then the other thing that I want to highlight is really that there is what I call a core technology overlap, where a lot of these core technologies that even if they want their cars to stay on the ground, they need to explore, okay? And these technologies are also, coincidentally or by design, the same set of technologies that's needed to enable UAM and flying cars, right? Firstly, electrified propulsion. For anything to, these days, partly because of, it is because of the green movement for sure, but it's also because of factors like noise, you want to fly near airport consideration where you want to land and things like that. You need electrified propulsion that's cleaner and quieter. So this has been in the development in automotive for a long time. And of course, you see that today all the major UAM players are also talking about electrified propulsion. So that's the first technology overlap. The other one is also energy storage. You probably will have heard about lithium, or even solid state batteries. And of course, today we keep talking about hydrogen as well. But this is also an area of energy storage where be it you want your car to, today if you buy a Tesla, okay, probably most of you wouldn't, but let's say your father or your friend buys a Tesla, right? Talks about buying a Tesla. The question is, what's the range, right? In electric vehicles, the number one question is, what's your range? What's your range? It's like your PSLE score. What's your range? So the range matters, and rightly so, right? Because nobody wants to spend time just constantly charging your vehicle or like constantly having range anxiety. So energy storage has become a big domain for the automotive player to play. And not surprisingly, if you want something to fly, you also want a lot of energy storage because you do not want to like have a 5-minute flight and then, okay, we need to turn back, right? And the other thing is also that you also need it to be light. So I think these are all like, as well as I think the other domains like safe. You have to be, because nobody wants something to start catching fire and it cannot be stopped, etc. So there's a lot of all these overlapping concerns about energy storage that automotive players, along with UAM players, have shared common interests and technology overlaps. And of course, the last point is about automation. Everybody talks today. Nobody is satisfied with a car that is even electrified alone only. Everybody wants their car to drive itself. Same for their planes. Nobody is excited anymore about or just about an idea of a plane, a flying car. Everybody wants a flying car that drives itself even, right? So there is a structured way of looking at this form of what we call autonomy, autonomy levels from 0 to 5. Nobody's at 5 yet today, but the idea is that everybody is working towards that direction. And be it in how Tesla is doing it, GM is doing it, or let's say other UAM players are doing it, that this automation technology, AI driving the car, artificial intelligence, being able to interact, be it through computer vision or sensors or LiDAR, whatever technology, there is a clear overlap in these fields about automating that driving or piloting experience. Okay, so there is a clear overlap. The other one is also a use case overlap. At the bottom left, you see what in your terms would be ancient. Is from 2016. Okay, it's by this group Uber, you would know, and they had this platform called Uber Elevate where they invited people to start dreaming back then, about 5 years ago, about a Uber-like concept where you just order your plane and then you fly, right? Flying by order. So they have already, that is the platform where these UAMs and everything arguably kind of really had a launch pad from, a launch from. A lot of these concepts were believed and calculated out of this Uber Elevate platform in 2016. So if you look at this picture, it's not immediately clear, but I want to let you know that these pictures, these lines here, the blue lines are routes by car. Okay, it's saying that if you drive, you're going to take 2 hours from this place to that place because of traffic jams and things like that. And then the yellow dotted lines are their proposal to you. Why don't you fly? Why don't you fly? If you fly, a 2-hour drive becomes a 15-minute flight, and you get to enjoy the scenery along the way, save time, and have a great time. So that is the use case of Uber Elevate back then in 2016. And not surprisingly, recently in 2020, Lilium, another major UAM player, also had espoused the same idea, right? That if you want the use case of a UAM is really, instead of driving 2 hours, 4 hours, you are going to be there in 15 minutes or half an hour. Okay, just as easy, just as even more comfortable, arguably. And then, so my point here is that UAM is not out there to replace let's say our equivalent of MRT or buses or any form of mass transport. It is not the use case, but the use case is to replace your 4-wheel vehicles, right? Your cars, your Toyotas, your Hondas, your Volkswagen, etc. So clearly, there's a use case overlap of a small group of people on demand at your own time, flying to covering a reasonable distance. So there's use case overlap in UAM and cars. And of course, if you are the automotive players of today, instead of being displaced by the similar use case DCs, you then want to join them, right? So that is the inevitability of car growing wings. The final point would be a bit more philosophical, if I may. It's really that there's this socialization overlap. And of course, in this socialization, companies are trying to talk to us about their messaging, about who they are as a company. For you guys, you'll be familiar with this at scale about, if I ask you what Apple is about, I mean, all of you have a ton of feelings about these brands, right? I think it is not that different in terms of how even a company like Joby or industries like UAM industry as well as car industries have come to that form of marketing concept. There's a socialization overlap, and today the socialization largely is about speaking to a generation like yourself about what the company stands for, not just in technology, not just in the service that they render, but what they stand for the planet, if I may, in a very broad sense, right? Look at Joby's company overview. I highlighted there, they talk about what they want to do, spend a decade developing and testing their zero emission aircraft. The point here is an argument of net zero carbon footprint, right? I think that is that is the buzzword of today. And you look to the right hand side, you probably wouldn't be able to tell which advertisement is from which player, but this is from Volkswagen's website. It says Volkswagen way to zero. Of course, it means zero carbon emission, zero carbon footprint angle. So this is really about this socialization overlap, that the car manufacturers, as well as UAM, they are not just telling you that I'm going to save you your time, I'm going to let you have a good time, but they are telling you that if you buy our product or use our services, you then can become part of this global movement of creating a better world, right? So there's a socialization overlap that car manufacturers are very much on already, and UAM is also pitching a similar idea. And of course, this convergence brings us to the inevitability of cars growing wings, that these two industries have somewhat come so close together that they are almost one, right? Okay, then the next thing, I think that's just a flavor about cars and skies, right? Hopefully that has given you a broad overview about how these industries are coming together. The other one, which I would like to talk about in greater detail, would be the core technologies that we see as important to enable cars flying in the sky. The first enabler would be electric motors. To enable flying cars, okay, you would need better electric motors. Lighter, quieter, more maintainable, and more importantly, certifiable. I'll elaborate a bit more about this concept of certifiability, being able to certify it, okay? So, I mean, the other thing is that Schaeffler, if you look at this picture on what I've shared here, the bottom left, Schaeffler has made many strategic acquisitions because we believe in this electrification movement of the world, right? We bought a company called Compact Dynamics. They do electric motor design. We bought a company called Elmotech Statomet. They do high volume production of e-motor machinery. So that allows us, with our unique appreciation of manufacturing and engineering ability, to mass produce high quality electric motor, which is the picture that you see here in the middle here, right? So our involvement in Formula E, the top left corner as well, you can see that we actually have a Formula E race team, which is electric. Formula E is the electric version of Formula One, right? And then because of our involvement in this Formula E race, it has allowed us to constantly push the limits of e-motor designs, like power to weight ratio, efficiency, things like that, right? That we have constantly been on. I think coupled with our EASA Part 21 framework, which I've kind of alluded to just now, that it allows us, from aerospace perspective, now we move a bit from technology to aerospace know-how, right? And this is really my point about certifiability. You can build something that's technologically advanced, but today, as you would see already, many people can build something that fly, air taxi that fly, but nobody has put it into full service yet, because there are challenges in certifying it to ensure that the safety and the rigor of traditional commercial aviation safety parameter, right? That you and I rely on every day when we go onto a SIA plane or any Scoot plane or whatever plane that you bought at Changi Airport, to make sure that, hey, somebody has covered the framework of safety behind this plane. So it is important, and all these frameworks are really covered by global organizations like EASA from EU, FAA from US, etc. So it is important that these technologies are certifiable in this broader safety framework. I think so. Here, this is what we have identified: electric motors as a core technology. What I would then want to share with you is what I think it would be implication for you guys today, right? I think you need to start thinking. I mean, if you were maybe you are a mechanical student, I'm a mechanical student, by the way. My point here is that the future is a mixture of both, that you need to think electric as well as mechanical, right? It's useful to think about trying to get things moving from a mechanical perspective, but today the reality is a lot of these are electromechanical. You need to think about electric. You need to be comfortable thinking about volts and watts and things like that as well. So this is one implication. If you don't know, go back to your notes and figure out your electrical stuff as well. Okay. The other thing is that if you're looking at a career that would say last you 40 years, so to speak, right? I think this is really an exciting area, electrical propulsion, and also material. So I mean, kind of a digression here, but materials, in my opinion, is also very important, because as these things move to a more cutting edge level, the material that you use, be it weight ratio or a conductivity ratio, truly matters, even a slight variation of it. And then the other point is also from a more aerospace perspective, you can find out more about the concept of certifying a flying car. It's not as simple as something that can fly will do. It's not like that. You need to, and then the question then is, what is needed then? I won't give you the answer here today because there's no straightforward answer. It'll take about five days to go through it. You can go and read up on EASA certifying framework, how all these, the likes of Volocopter and other companies are looking at their certifying framework. You can go online and research it. But I think this will be interesting as a student think about, because if you do join this industry, I think this will be a large part of your work. More than pure technological breakthrough, it will be a large part about how to harmonize this technological breakthrough back to a certifiable framework in the existing commercial aviation industry. Okay, so this is the first point on electric motor. Second, technological enabler that we believe is important in making flying cars truly be able to fly is cloud-enabled condition monitoring. There are actually many layers of points. There are many points here. I'll go through them one by one. Firstly, in the eVTOL or UAM operation, by design, it is short duration, right? If not, you can drive, right? If it's very large, very far away, you also don't want to take a eVTOL, so to speak. You take something like a train or whatever. And it's over large area. That's the whole use case, right? Fly over something quickly and rapid turnaround. I think if you read at the investment thesis of Lilium, they'll tell you that each vehicle, each day is supposed to generate $15,000. If I'm not mistaken, you can read up on this. So the point is that to make it work, it needs rapid turnaround. You need to constantly, like a super grab, as you can imagine. The driver has no time to wait, man. Just stop and then go to the next destination, pick up the same passenger, and keep going and going and going and going and going. There's no stoppage time. So you need a rapid turnaround. To enable this, you need some form of condition monitoring, because you cannot allow downtime. You need an incredibly high uptime for this eVTOL commercial model to work, right? So because of the large area, I think some of the parameters that's needed in this condition monitoring system will be this. It has to be cloud enabled, so that anywhere, anytime, it can be accessed by a set group of people. You need to be manufacturer agnostic, because there are so many different brands of people that are building different things today, right? There's no standardized, there's no standard, so to speak, on what kind of condition monitoring tools framework do you want to use. So yes, the solution needs to be manufacturer agnostic. It needs to be scalable, it needs to be expensive. It needs to be learning. Learning here, I mean like machine learning with a bit of AI and things like that to spot patterns, identify trends, and do predictions, right? And it needs to be a basis of actionable maintenance insights. You do not just want to collect data for data's sake. You want to collect data so that it can be used for meaningful maintenance insights to increase your uptime of the vehicle. So here, an example is what we have here. I already put it here on the screen for a while. We have this thing called uptime, which is a vibration monitoring only. I want to say it's only measuring vibration, but it has all the features that I talked about. It's plug and play. It works on all machines. It's Internet of Things, cloud enabled, blah blah blah. But more importantly, it is learning. It takes a vibration pattern, and then we use AI and machine learning to understand what's going on, and then to provide as a service meaningful insights on what is happening to your machine and what does that mean in terms of maintenance action. I think here for students, right, I've talked about this technology, cloud enabled and condition monitoring. The goal is really that it should be that for students today, you need to understand that the world has moved to a point where data is king, right? It's a cliche to say today, but yes, data is king. You need to collect, lots of data will be collected. And to manipulate those data, you need, as a student today, you need to be reasonably familiar, at least from a conversational perspective, to talk about the idea of coding. You might not be the guy coding, you might be project managing these people who code, might not be working in Singapore, but you need to be able to talk their lingo at least. So I think what's important is really you need to be familiarized with things like languages like Python or R or whatever else language their school is teaching you. Take those lessons seriously, and then truly code. Don't ask somebody else to do it for you. Do it yourself and really get a good grasp of it, because it is important. And you need to be able to understand big data concepts. different way of manipulating data, different tools, Hadoop, whatever, that things that are out there. You need to somewhat get a grasp. You need not be expert on it, but you need to have a working knowledge on it if you want to go into this field, or if you want to project manage a bigger thing, you need to minimally be at a conversational level able to talk about these things. The other thing is also you need to understand the need for predictive maintenance. Like what I talk about, data should not be collected for data's sake. Data should be collected for end use sake. And in this case, because we are talking about mechanical device, right? UAM is a flying machine, right? You need to have predictive maintenance actionables that, okay, this thing is vibrating this way. It means that in the next 5 flights, something will fail. This is the thing that will fail. Replace it now if you do not want a downtime, something like that. So this is absolutely important. Predictive maintenance is already a big topic and industry in, let's say, the commercial aviation, Airbus, Boeing. They're all working on some form of predictive maintenance framework, health monitoring, etc., whatever you call it. But the point is, this predictive maintenance is an important part of this industry. And I think I hope I've given you some implications of what you can do as a student today. The third technological enabler that we foresee is that we need some form of a steer-by-wire concept, some form of actuation system. Electrified AAM or UAM vehicles require some steer-by-wire solutions to actuate control surfaces. Because if you look at the latest design, even from our friends at Volocopter, they talk about a tilt rotor concept where you vertically take off, but you need to turn the rotor so that you can fly forward, or they have some wings or control surfaces that you need to actuate. So we're talking about something that needs to move in flight, right? So you need something to actuate it. So at the moment, there's no mass market ready product in this class in terms of steer by wire or control by wire for aerospace. So I mean, what we have here is that we have a paravan. Okay, I'm not selling this thing to you, but I just want to let you know that this is what Schaeffler has been doing, and and it shapes our thinking quite powerfully as well. We have this Schaeffler paravan space drive. It has more than 1 billion driven kilometers. It was designed for disabled people to drive the car. So it's a joystick system that you see in the middle of the screen, right? It has more than 1 billion driven kilometers. It has triple redundancy by design. It is integrated into more than 8,000 vehicles globally. It's a viable foundation for any steer-by-wire concept that we believe is needed in the AAM or UAM industry. I think what I would share in terms of what it means for you then is that, sorry, there's a short of an E there, but the point is really that as a student, you need to see that while I think I've convinced you that the world is going electrified, but I also want to let you see that while it's electrified, we live in a brick and mortar world. You live in a house that's built physically, right? Because of this reality that we cannot avoid, no matter what happens, we need something mechanical to deal with the physical environment as well. Anyway, but let me go back to my first point first. Electrification and electrified, what I want to type there is electrified actuation is actually an enabler of autonomous driving. Because like I kind of alluded to autonomous driving just now, right? But I want to say that, or rather, it's generally accepted that for anything to be autonomous, you want a computer to guide it, you need an electrical system so that the computer can control electric motor. A computer can't control a ICE, let's say a combustion engine, traditional combustion engine, as well as an electric motor in general. It's not that it's impossible, but it's a lot more work, right? Because if it's electric, you just control the voltage and it goes. But if it's ICE, you have to control a lot more things, right? How the fuel goes in, blah, blah, blah. So it is a lot more complicated. That's why the first point I want to highlight is that you need to understand why people are driving towards electrification, because it is a middle ground. It is a necessary step for the whole autonomous world that I think you kind of believe that will happen to you in your lifetime, right? And then the other thing that I've kind of alluded to just now is really that we acknowledge even the best electrical system needs to deal with the mechanical aspects. So like what we are doing here, that even your whole car is electrified, you need something to actuate the mechanical surfaces, be it the flaps or tilting the rotors, or in a car, steering it left and right, okay? So this is what I want. I think as a concept, I hope to leave with you to understand that the world is going electrical, but you still need something mechanical to deal with it because we live in a real world. The other thing that I want to highlight here is really that how we talk about our space drive technology, or why did we work with Paravan on it, is really that they have a track record. They have reliability, more than 1 billion kilometers driven, triple redundancy by design. This is also one of the kind of challenges that we have. If you ask yourself, why are there not more flying vehicles in Singapore today? It's not really that there is that we cannot get it flying, but it's really that we cannot have a thorough, comprehensive framework of certifying that it is as safe as everything that we expect it to be in this, with this public liability and things like that. So the value of reliability and track record is very, very important, because it undergirds the idea of certification, and also it also affects the concept of socialization. You, as a person walking around Singapore, will definitely not want anybody to recklessly just put some flying thing above your head and potentially cause you harm, and then the government does nothing about it. Of course, you want the government to have a robust framework around it and things like that. So how do they do that? They have to base it on value of reliability and track record of the product and all the designs in place to ensure redundancy, etc. So I think this is important, and then of course I think these are the 3 points I hope to leave with you on this, thinking about this, right? And then finally, the second last point is that we talk about energy storage, and specifically I want to talk about hydrogen. That I think we are part of a growing eVTOL, or UAM is really not a standalone economy. It is part of this green economy, and hydrogen in its various form will likely be adopted as one of the key energy storage solution, either in a fuel cell form or pure hydrogen form, right? I mean, if you're interested in it, you can read up more on hydrogen topic. But the main thing, coming back to our application, is really that if you want longer range, you want higher payload, you want to carry heavy things, you need to go beyond the batteries of today, honestly. If as today, there will be a limit in terms of the energy density that today's battery has, even theoretically, right? So we need to move towards something maybe like hydrogen or something like that. Okay, we don't know the answer, but Schaeffler joined the Hydrogen Council in 2020. It's a global thing. It's a global council to drive hydrogen initiative globally. And then my point here is really hydrogen. I mean, I don't have a crystal ball. We can't see exactly how it's headed, or we can't dictate it fully. But hydrogen is an industry that's still growing, nascent and young. And commercialization push will likely come from automotive, with a spillover to UAM, air taxis, etc. Okay, and we should expect that to come together. We, as Schaeffler, we do expect that our investment in automotive will then be able to be plowed back into our aerospace business. And then the implication for you today is that I hope, if you are not already familiar, you should know that a lot of technologies today, the bottleneck is not with the electric motor. It is really with the energy storage technology. Okay, so the point here is that if you are interested in looking at a career, what you want to do, and somebody talks to you about energy storage, don't just think like, oh, battery sounds boring. It is not boring. It is the bottleneck of many, many things today. You can truly carve a niche, an edge, or even start your own company if you have some patent around it along these lines: solid state batteries, lithium, hydrogen fuel cells, etc. So I think this is really what I hope to leave with you, to understand that batteries, you look at Energizer or Duracell, you think that why we want to do anything with it, it doesn't even move. It is not boring. It is actually very, very cool and exciting. So I think this is one thought that I leave with you on this energy storage and hydrogen. Then finally, I want to say that AAM, UAM, air taxi is a part of the burgeoning green economy. Manufacturers and service providers need to not just have green projects. They cannot just say that I plant trees, or I got solar panel installed on my factories. Those are good things and necessary, but they need to embrace sustainability as a strategy. Okay, so this is just what I want to share from as a flavor. Like even Tesla recently, right? Of course, more recently he has gone back and forth on it. Tesla talks about no longer accepting Bitcoin over climate concerns. So just a thought. You would think that if you are a car or you think that you are a manufacturer, you just need to manufacture something that is good like a electric car, good for the environment. And then the next step you think you have already gone beyond is that I need to manufacture it in a green way. The way I manufacture it must be cutting edge. Don't create a lot of pollution in the manufacturing process. You think that that's good enough? Usually that's good enough. But today, even peripheral things about how you collect your money. Do you collect Bitcoins? Do you collect cash or whatever? Matters as well. So the point here is really that holistic appreciation of who you stand as a who the company stands as a what the company is about in this green economy matters holistically, right? That's why Schaeffler is also, we also do our part. We are recently nominated as the 50 sustainability and climate leaders by United Nations. It's just because we also take this seriously, and we have that to show that people agree that we are taking this seriously. I think coming back to you, right, students today, I think what is important is really consider that how you know, be it what you know, your engineering know-how, your technical know-how, your marketing skills, your sales ability, whatever you're learning in school, consider how what you know or are learning can be applied in the booming green industry, right? And you should be thinking about how, be it in the aerospace industry, how things like solar, wind, or carbon capture can be a factor, a function of this industry, the aerospace industry in general, or the STEM industry, and apply your knowledge and know-how to make this world a better place, because it is a core enabler of AAM, because that's how we are part of the green industry, and more importantly, we are a humanity that we need this to keep us going, in the long run as a human race. Sounds cliche, but that's true. Okay, finally, I just want to give you some platforms to reach out to us. I think that's part of what I share in terms of content. I just want to say that a lot of things that I talk about here to you are really technologies that are still growing and under development, as you can imagine, right? You look up to the sky today, no flying taxi yet. Soon, right? Soon, but not yet, for good reasons, because a lot of these are still under development. Therefore, we also have in Schaeffler, we have many what we call a share network. Share network is really where we have strategic partnerships and working relationship with global universities. So you can see that we have that in US, Germany, China, and in Singapore, we have this facility at NTU as well. Share at NTU is focusing on robotics as well as urban mobility, innovative mobility, which includes AAM, UAM, and flying taxis, etc. So we also have a plug and play framework, which is more on the venture capital side, working with startups. So if anybody wants to, you start a startup and you want to engage somebody to work with corporations like Schaeffler, you can go through this plug and play framework that we have. Okay, so and of course I left some of our contacts here. You can contact myself, you can contact my colleague Kelvin, or you can contact my colleague at Share NTU, Boon Xiu. Our emails are there. If you have any ideas or any thoughts of working with us, you can feel free to reach out to us, or if you have any questions for us, feel free, right? So I think that's all I have. I just remind you that Schaeffler is a business of pioneering motion, and we're very proud of what we do today, and we look forward to doing more for the world and for mobility altogether. Thank you.
Thanks, Ian. I think you made a very good point about holistic approach to manufacturing and thinking about how to be relevant to the green future. It's inevitable. Right? We enter questions and answers. There are a couple. So the first question being, would these developments allow for new career opportunities in the aerospace industry in the next 10 years? I think I think you answered a little bit on this, touched a little bit on this in your sharing. Obviously, with the new technologies coming up, batteries, green. But
yeah,
any pointers you want to add to this?
About career opportunities, I would say that definitely. Okay, firstly, if I create, I think I can create a framework for students to think about it. Firstly, we need to see that there is the industry is complex in the sense that there are fundamental science that is important. So there are organizations like A-Star or whatever who do fundamental scientific research. That can be a career if you want to be a research scientist, right? So let's talk about battery, for example. If you want to go to this level, then you will be looking at molecular structure, like what happens when you increase this or that, doping the material a bit here and there. So I think that is at the fundamental science research level. Then there is a bit more of the component level. So if you want to talk about UAM, there are many components, right, which I've kind of alluded to: propulsion, energy storage, or even composite materials. I didn't talk about that just now, but composite materials. These are all the component level. So you can also join a company to do this, right? Or you can join Neo Aeronautics to do this, which probably will be the third part, which I will call integrators, right? Integration, this part, which I'll say integrators. So there are three parts to this: fundamental science, component manufacturing, and then finally the integrator part. So integrator will be maybe arguably like Neo Aeronautics, where you guys do not try to produce the best individual subcomponents assemblies, right? But you want to be the integrators. So the likes of Neo or like other companies, say even like maybe Volocopter or Lilium, where they are trying to integrate these technologies together and then have a revenue model behind it, right? So it's a bit more complex at this layer, but going back to that question, I would say that there are kind of career opportunities, but I hope to give you this framework of thinking first: fundamental science versus component level, and then integrator level. You think about which excites you, and then you can delineate in the fundamental science, what you want to look at, right? And if you want to do components, then what you want to do, Then if you want to be at the final, it excites you to be, to be in the vehicle itself, then it's another level together, right? Then you need to get there to the integrator. So it really, my answer to you is that there are all these jobs within these categories. This is not the only way to slice it, but that's my way of slicing it for you. And within each one, you can systematically look through it. Yeah. In Singapore, I just want to say that there are definitely many opportunities, even with Temasek Link organizations that are doing this kind of work. We're not naming names here, but just go and figure out like what are some of these companies that are listed in Singapore that they are doing something in this field, mainly on the integration side, if I can allude to. A lot of Singapore is on the integration side. But of course, if you ask me, if you are cool and excited about the component side or the fundamental research side, please go ahead. You add to the depth of our capability to offer something as a nation. Yeah.
Tons of opportunities. I think you give a very good framework, 3 ways to think about it. So thanks for that. Can we take the next question? Would the usage of flying cars in Singapore be a problem with our high-rise and densely packed buildings?
Well, I'm not an expert on this, but I can tell you that Singapore is interesting. We have actually mapped out the city 3D. I'm not making this up. It is real. That means you say that we have high-rise, right? That's true. And you are assuming in this question, I suppose, that there is no, you fly over a building, we don't know there's a building there, we don't know the height. That's not true, right? I'll let you know that Singapore, somebody has already mapped it. I think you go to one map, you can find it. The 3D landscape of Singapore has been mapped. Sorry?
Is it by Schaeffler?
One map, I think. It's not by Schaeffler. No, it's not. You shouldn't. I mean, you should. I think we can find a link later, but if not, you can ask our friends at AIS. They are the ones who linked. They had a robust discussion on this about air traffic management, because that's the air traffic management topic, right? Air traffic management. So people have done a lot of work behind it already. I cannot claim their credit, but I just want to say that Singapore, just to answer the question directly, I hope it gives you a framework, because underlying in that question is that you assume that a plane flying over will not be able to tell that there's a building here. But the answer is it can, because the 3D landscape of Singapore has been mapped out already by somebody. And then, so to answer your question directly, there are two parts to solve this problem, right? One way is proper traffic management with proper mapping, which I think we already have done. The other one is sensors within the vehicles itself, which is also super robust, super complicated, super sophisticated, just as a flavor, even in, but it's not new, so to speak. This is not new, because even in the general commercial aviation, there is such a thing as what they call ADS-B, in commercial aviation, ADS-B, where they beacon to each other where I am. As in planes to planes, they talk to each other, where I am now, what altitude, what speed. And then the computer then calculates that, oh, I'm actually near you, but I'm at a different altitude. So then the computer will decide, so I should fly higher or lower, I should pass you, etc. So there is such a way to avoid collision already, even in commercial aviation framework. So I won't be surprised that some form of this would be applied maybe in a less complicated, sophisticated sense back into UAM or air taxi. But at the same time, to avoid buildings, you can also implement some form of sensors in the building or by just mapping that I've talked to you about. So my direct answer to you is I don't think that'll be a problem because there are very brilliant people who have done a lot of work thinking about this problem already. Yeah.
I think we found the one map. So for anybody who is interested, you can refer to the link to the chat.
Cool.
The one map.
Yeah.
This is about yourself. What educational path did you take that led you to the field of aviation?
Okay, wow, this is a good question. I did mechanical engineering at NUS. Okay, mechanical engineering. So if I can share a bit more, can, right? I don't know, time wise, okay, can, something like that. I would say that it's really interesting because since you asked about me, right? When I graduated, I had different job opportunities. I had construction. There was opportunity to work with a PE company to do construction. Mechanical engineer can do construction, right? And then there was also I could also work at a shipyard, shipbuilding, right? And yeah, so construction, shipbuilding, and then there was an opportunity at aerospace. So I eventually took aerospace because it sounds cool, I guess. So I took aerospace. That's the reality of how I came into aviation, right? In aerospace. So of course, then like what they say, the rest is history, But I think this question, if I may just build on it, I want to say that actually we are very fortunate that in Singapore, you truly have a lot of opportunities, right? Even within if you whatever degree that you take, right, you truly have a whole domain of opportunities to go into. I would say that for me, coming into aerospace was exciting and fun, and now that with this AAM and UAM kind of development, I think it's like a second spring to anybody in this industry, our career path. All of a sudden it opens up another whole new domain again, and it's totally new, and we are kind of like the aerospace people, so to speak, because nobody is truly a UAM player fully, like 20 years experience, right? It didn't exist 20 years ago. So it is quite interesting. Yeah, I would say.
It's a level playing field for everybody.
Yep.
How would carbon neutrality be achieved in countries like Singapore, where electrical energy is produced using non-renewable means?
Wow, this is a EMA question. You need to talk to energy market authorities, but agency. Anyway, this is outside of my scope, but I've talked to many people about this as well, so I can try to answer this to the best of my ability. So, how can carbon neutrality be achieved in countries where electrical energy is produced with non-renewable means? Firstly, we are producing a lot of first cut. I think what's important to understand is that Singapore is working very hard to. I'm representing Singapore government now. We're working very hard to implement solar renewable resources, right? First cut. Even this one can share in terms of aerospace industry. Recently, AIS, which is the Association of Aerospace Industry Singapore, has worked with JTC, right, to implement to find out solar uptake in terms of all the footprint factories that we have in Singapore for aerospace industry, and what's the solar uptake, and then they come out with commercial plans for people to take it up, and it's like kind of funded. Somebody funds it, and then you just volunteer a rooftop, and then you collect they basically rent your rooftop or something like that. Where my point here is that this notion that we are purely on non-renewable means, it is true, definitely, because it is not going to replace 100% of we still need power plants, right? But it's increasingly shifting that we are also moving towards renewable means. So that's my first point, right? On be it solar or whatever. And then the other concept is offsets. Carbon neutrality can be offsets. Like, it's very, very trendy in the aviation world today, that when you buy an air ticket, if you still remember, like 2 years ago, when you buy air ticket, some airlines will tell you what's your carbon footprint, and then they'll invite you to buy offsets. Offsets meaning to say that you buy some carbon in Singapore. There's a framework as well lah. Oh, I'm going into too much details here, but energy market company, right? As a private company owned by SGX, I think they also have this network where you can trade renewable energy certificates, where it says that, oh, when you buy this, you're offsetting 1 kilowatt hour of energy that you consume. So in the same way, carbon footprint offset in airlines is also similar concept lah. You can pay a sum of money to offset it, so that this money is either used to subsidize renewable energy usage or to build more capacity there. So to answer your question, I don't think we can reach carbon neutrality. It's not for me to answer lah. We need the ministers to come up with a roadmap. I can't answer it here. But first, I want to say that we are clearly exploring it as an industry, with the JTC and AIS work already on renewable energy sources. At the same time, as a nation, we can do these thing offsets in the interim lah, while we figure out how do we reduce our carbon emission footprint. Yeah. Okay, but slightly off topic here.
Yeah. Obviously, we are still early days now, but thanks for sharing with us your insights on this matter. And the last one being, would nuclear energy be a viable energy source for the development of flying cars?
Well, if you ask Rolls-Royce, I didn't say this. I don't. It's not private information. You just go and Google Rolls-Royce UK kind of strategy. They'll tell you nuclear, miniaturized nuclear power solution is the solution to everything. Okay, that's true, because I mean, I to answer your question, I don't think that the answer is to build a nuclear power generator in a vehicle. So answer that is no. But nuclear will be used as a power source to generate the hydrogen that you need, or to charge the battery that you need to put onto these flying cars. You understand? So it is part of the solution. And just to build on what I've talked about Rolls-Royce, these are all public information. I don't represent Rolls-Royce here, just to be clear, because it's recorded, right? I don't represent Rolls-Royce here. You can go Google online, Rolls-Royce and UK government master plan about these things. Rolls-Royce will tell you that based on their experience of building miniaturized nuclear generators in nuclear powered submarines and boats, and the sorts of things, they are able to do this in a very small scale footprint and very safe, very clean, right? So I think I am of the opinion that yes, nuclear should probably feature somehow in the renewable source thing, but not as a standalone generator in every car, just to be clear. But the nuclear centralized would be used to charge the batteries that you want to put onto the car, or to generate hydrogen cleanly to be used as fuel cells or whatever. That is my take, and I honestly do not know what is Schaeffler's take on this, but this is my personal statement. Yeah.
Thanks for that. Yeah, that was the last question. And
Yep.
I think on behalf of the audience, I'd like to thank you very much for being here with us and sharing with us very broad, varied topics about the aerospace industry and about what Schaeffler does. So thank you once again for joining us today.
Yep.
To the audience, if there are any more questions that were not answered, or if you think of any later, you can put them through to us on our YouTube for Aspire Incubation Labs. Coming up today, in a short while, we have Mr. Nicholas Ang from F Drones at 2:15 p.m. Who is CEO and co-founder of F Drones, and he'll be discussing with us some of the business applications of drones and some of the very exciting career opportunities that the industry has to offer. So stay tuned. And for those who have not already signed up, this is on the 1st of July. We have at Astra, astronaut Jeff Williams, who will be here with us on 1st of July at 9 p.m. So there's a link to sign up, and you'll be prompted to do so after this session. So let's break for lunch, and then we'll see you back at 2:15 for our session with F Drones. See you later.